test, we're going to be reviewing the pictures, and once we review the pictures, we're going to log them by hours, and we're going to count how many mutation cells have happened. But we have to take note of the environmental effect around it. So here are the three sensors: temperature, humidity, pressure sensor. Then there's the light sensor, and then there's the radiation sensor. We got to take note of each environmental effect to see how each affects the mutation rate, and they're going to be logged into our SD card in the NSC board. Once these are logged, we're going to test our hypothesis, and our hypothesis is, will the E. coli mutate faster in microgravity than on Earth's gravity? And I'll pass it on to Andrew Frank.
So basically, we have all these sensors, and we're trying to get the environmental data back so that we can run a similar test on Earth, as close as possible to the one that's running on the space station, except for gravity. And so that's why we have all these sensors. We actually had so many that we had to use an inter-integrated communication system because we didn't have enough inputs on our NESI board, which was provided by Texas A&M. Next slide, please. So the organism we're using, we froze it in negative 20 degrees Celsius freezer, and that's to ensure that the experiment doesn't begin before it actually gets to the space station. So here you can see that's our NESI board. We were soldering wires directly onto it, and it was causing a lot of damage. So if you go to the next slide, you can see we have a custom circuit board that holds two cameras and the sensors to monitor environmental variables within the chamber, as you can see here. If you go to the next slide, you can also see this other custom board that we've created, and that connects everything. It really cleaned up a lot of the wires for us. If you go to the next slide, you can see this is a sketch. We tested a bunch of motors to find the perfect one that worked with this test. And this is just a sketch of one of the assemblies we used for testing it. If you go to the next slide, you can see that we are not the only people working on this. There's like a whole team behind it. You can see us. We took a picture with Mark Polinsky, who was an astronaut on the ISS. And if you go to the next and final slide, you can see all our sponsors that we would like to thank for helping us out. And now I'll pass it off to our adult leader, Mr. Norman McFarland.
Hello, everyone. As project leader, I could not be more proud of this boy. I could also use them. As project leader, I couldn't be more proud of these boys. They started off as a bunch of bright-eyed school students, and now they're self-starting, problem-solving young engineers. They're just doing they've done a phenomenal job. For those of you that think that scouting is all about camping or campfires or knot tying or whatever else your preconceived notion, maybe you can see now that we do some STEM stuff once in a while. We actually offer over 60 merit badges in the science, technology, engineering, math area. In addition to that, we have several different Novus awards for special studies into the STEM area, and beyond that, once you have some NOVA awards, you can earn Supernova awards, the top of which belongs on your college resume as a significant event there. So our team would like to thank NASA for this TV time, CASIS, NanoRacks, Texas A&M University for sponsoring this team, General Kinetics, EBPI was our biology source, and Spark Fun for many of the sensors that you saw here. Finally, we have a very special thanks going out to two people, Nan Elder and Lisa Early, who were former Scout Council and District STEM professionals that set up